Hello everyone, welcome back to the video. So today we are going to see problem number 1504, count matrices with all ones. Okay. So in this given a MX binary matrix mat, written the number of submatrices that have all ones. Okay. So we are given with a binary matrix that will contain only 0 and 1, and we have to find submatrices such that it will only contain 1. Okay. So it's similar to yesterday's problem. Yesterday we have to find the square submatrices, and here we have to find all submatrices. So let's see in this like how we can make it. So first we'll try to include one by one. Okay, one into one square, one submatrix, 1, 2, 3, 4, 5, 6. So it will be 6. Okay, then we will try to find one by two. Okay, that is one row and two columns, so it will be, I'll mark in red, you guys, this one and this one, this two only we can find one. So I'll just remove this. Okay, one by two, we saw one by two is two. Okay, again we will try to find one by three. Is there one by three? No, I'm not able to see any one by three here. Okay, then we will try to find two by two, two by two. So I can see only one 2 by 2 here. Okay, this one. So we'll include that, equal to 1. Okay, then we'll try to include uh, 2 by 1. Okay, that is this 2 by 1. This is also 2 by 1. This is also 2 by 1. Okay, so we can see 2 by 1 are 3. 1 equal to, there are 3. So here we are missing 1 by 3 actually. This one also we should consider. So 1 by 3 will be 1. So this will all give us as 13. Okay. So total submatrices with 1 are 13 here. So I'll just erase this one and we'll start fresh again. Okay. So hope you get it how many submatrices of 1 we can make. So let's try to find how we'll create this. So in the previous problem yesterday we saw that we found the squares with by a DP approach, and in that we were finding the index and the number of squares that are ending at that index. Okay, so we'll try to find something like that only. So if I see, if make a same 2D array here with the width. Okay, with the width, so here it will be 1. I'll change the pen. Okay, so I will calculate the continuous width. Okay, so this will be 1, this will again 0, so it will be 0 only, this is 1. Okay, then again we'll calculate this will be 1 initially. So 1 plus 1, we can see it is 2 here because these two are contiguous, and it will be again 0. So here also 1 and 2 and 0. So this is not DP, but just we are making an array here. Okay, just for calculating the continuous width. Okay, for that index. So for index 1 it will be only 1 in this one also, but here we see we have a contiguous 1 here, so that's why we have written 2. Okay, so hope you get this one. Okay, now we'll try to find with this. Sorry, yeah, I erased this. Now with this we'll try to find our answers. Okay, so we'll take a variable answer. Okay, and initially it will be 0. It is 0. Okay, so we will start with index 0 0. Okay, we'll just number it 0 1 2 0 1 and 2. Okay, so for the 0th index, this one will start, and we'll see in this array how much is the width. It's 0 only, correct? And we will move upward. Okay, we will move upward like this to see if more sub arrays we can create with it. Sub matrices, sorry, it's not sub array. Yeah, but at is 0 0, and if we move upward it will be out of bounds, so we'll stop here and just add 1 here. Okay, next we'll move to 0 again. Add this is 0, will not include anything, will not do anything, and we'll just skip because in our condition we want only ones. Then we will move to this one, that is 0 2, and we will add 1 here. Yeah, and we'll try to look up again, and at the left also we'll try to look. Left we have already calculated, the width is completed, like from left to right we know how much is the width of that index. We're just looking upward for the length of the height. Okay, so we have out of bound, so we'll only one. So this first row is completed, we can say. Okay, first row is completed. Okay. Like so next we'll start with the second row. Okay, this one I'll take a different pen for that. Okay, so with this, when we start initially, let's give this as a width. Okay, w width array. So width array having one, so we'll add one here, one plus. Okay, then will it will look up. Okay, it also has a one, so one, and it will take the minimum of both. We'll take the minimum of both what we can make. So we'll make one here. Okay, because one for itself and one with this, it is ending at this one. Okay, like one itself and one this one. Okay, so this make two, so we have already added 1 plus 1. Okay, and after reaching this it will be out of bound and we will exit that. Okay, I'll just give a comma here that we are starting with this one now. Okay, so it is already 2 there, so we'll write 2, and it will go upward and 0 and it will return back. Okay, so these are also we are going to add. Okay, and then comes 0, so 0 will do nothing. So in this way second row is also done. Okay, now comes the third row. Third row we have this one. Okay, so again we'll add 1 plus, again we go up to index 1, we'll add 1, again we go up, we'll add 1. Okay, so in this way this index is done, this one is done, then move to next index. That index we have 2 because we know this width is 2, we'll add simply that width. We'll look up, we'll take the minimum of 2 and it's 2 only, we will add 2. Okay, so how this 2 is coming, you must be wondering, right? We have only one, so I'll show you, just give me 1 second. I'll just erase this and show you for this index how 2 came, right? 1 1 1 1. So this index we are talking about, I'll take a red pen. Okay, this index, so first it itself is there, so that will be 1. Second is this, third is this, and fourth is this, all four. Okay, so you got it, how with this index we are getting 4. Okay, so in this way we'll calculate, and if we add it, if you can see, if we add it like 1 1 plus 1 2 3 4 5 6 7 8 9 10 11 12 13, so it will give us the same answer, 13. Okay, so hope the approach is clear now. Okay, and we are doing it, and for this now you can pause the video and try to do it yourself, or we'll going to the compiler and do it. So follow the video for that. Okay, so let's do it. Yeah, we'll first make an width array of 0. We are making it same length and row and column. Okay, then we will be iterating. Okay, also we'll take an answer in which we'll store our count and return it. Okay, then for int I equal to 0, mat dot gth length I plus plus. Okay, and as it a matrix we need to write this also. Okay, so while making this we will also create the width array. Okay, so if j is equal to 0, that we have nothing in the backward side, so we'll just put width width of, but initially it will be 1 only, right? So width of I and j will be, equal to mat of ij. So whenever we'll be at 1, okay, whenever will be 1 this row, so there is no backward element or present, so we'll be just assigning it with 1. Okay, else what will we do? Suppose we are at 1 here, so we need to check if we can increase the width of that. So we'll check it with else. Suppose width width of I and j equal to, if mat of I and j is equal to 0. If it's 0, then what we have to do, we have to include 0 only. Otherwise, we will do width of I j minus 1 plus 1. Okay, if it's not 0, it will be 1, so we'll just adding its own value and this previous value. Okay, and this is how we are simultaneously creating our width array also. Okay, we are not pre-computing it, in the iteration only we are creating it. Okay, now we will see. Okay, now our array part is done, computation part is done. Now for this array we'll write another for int x equal to I should be greater than equal to 0, I plus plus. So for the current I, we'll moving upward, correct? Yeah, and we will be calculating with that only answer plus equal to width of, okay, we'll take a current here first. Okay, int current equal to width of I and j. This will keep this is to take the minimum of both. Like when we traverse from down to the upward, it will keep a track, and just we'll do like answer plus equal to current. Okay, and if it's 0 only, then we will not do anything. If current is equal to 0, we'll just break it. Okay, so that we don't iterate for that. Current equal to math dot min of, okay, this we have to keep it here, the math dot min of current comma width of I and j, not ij, sorry, it's x, so my mistake. This can happen with you guys also, so be careful. Man not min width not, if current is equal to 0, if we get a 0 upward, then we can break it directly and answer plus. Okay, so that is fine, and we'll just return this answer. Okay, let's try to run it. Okay, we get some error for int j equal to mat.length. Okay, j should be less than, oh, I think here j will come equal to 0, j should be less than. Okay, I think this is fine. Now 716 is also an error. Yeah, we forgot a semicolon there. Now here it's telling array index out of bound. X should be greater than equal to 0. X plus plus, no, we have to do minus minus here because we are moving backward, right? So that's why you get an error. Yeah, it's working completely fine. Let's try to submit it. Yeah, it's working. So for this, right? So we'll just add a page here. So for this, the solution we are iterating, like you can see, it will be big of n m square into n, and space complexity will be mn to n. I'll just show you how it is. Okay. So if we see here, this is the first loop, this is the second loop, and inside that second loop we are also iterating for n, means the height. So that is, it becomes n cube. Okay, and for this we have made one mn, so that gives us space complexity for mn. Yeah, so our one approach is complete. Yeah, so we have solved this example, but the time complexity is too much. So there is a better way, slightly better way to solve this. So instead of this loop, we can use monotonic stack here. The stack with monotonic, okay. If you don't know monotonic stack, just go to some video and look into monotonic stack. It is simple, okay. And this solution that I'm going to show is not that will come intuitionally to you. Okay, this will need a lot of practice, and you have to solve a lot of problem, then only you can understand, okay, I can solve this problem like this also. Okay, so let's go to the board and take some example, and I will try to make you understand how we'll solve this with stack. So so initially it's let's take this first row. Okay, take this first row, 1 0 and 1. Okay, got it. Yeah, and then we'll use a stack for this. Before that, I will show you how we are going to calculate that. Okay, we are going to use the same thing, enumerations. Well, we're going to go everywhere and calculate, but the stack will give us the previous element directly. We don't need to iterate for everything. We'll just get the width and the length, and we can multiply it and add it like that. So I'll show you first the iterations, and then we'll talk about it. Okay, so let's take first this one, the one. Okay, so for one, what is the previous index that is lower than one? Okay, it is minus one. Okay, because it's on zero. This is on zero, so it will be 0 1 2, and here it is minus one. So we need to find an index which is less than this. Okay, less than, which is having a number lower than its height. So its height is 1 here. This is height actually. 1 here, height is 0, here height is 1 again. So we find it, so it will be 1. So we'll just add here, we will again take an answer. Okay, we'll add 1 here as it is, because 0 minus 1, it will be 1 only. So 1 into 1, it will be 1. Okay, then we go to the next, that is 0 here. So for this 0, we'll do nothing again. Yeah, then we'll go to 1. The index is 2 here. Okay, the index is 2. The previous index, which is having the lower element than its height, is 1. 2 minus 1 into the height. We'll take into the height. So it will be 1 into 1, because height is 1 only. So it will be 1. Again, we'll add 1. Okay. Next, we'll again make a same array, the height array, and we'll compute it. Okay, I'll just make it. So here it was 1 already, so with this index it is 1. So we will add the previous number here, so it will be 2. Okay, so again here it is 1, we'll add the previous number, it is 1 only. Here it is 0, so we'll write directly 0. In 0 case we'll not add it, because it's not contiguously we are getting the height. Okay, here comes 0. Okay, so now for this we'll calculate. Okay, so for 2, right, again for 2 we'll say same 0 1 2, and this is minus 1. So what is the previous index? That is minus 1. Okay, so 0 minus minus 1, that will be plus into 2, it will be 2 only. So we'll add 2 here. Okay, I'll just erase this and write the calculations here. Then we'll go to 1. Okay, then we'll take 1. So what is the previous index of an element which is less than 1? It will be again minus 1, because 2 is greater than that. We cannot include it, right? Like it will be have a 2 and this is 1. So we cannot include that. We need something less than 1, the height. So it will be minus 1. So again 1 minus minus 1, okay, into 1. So it will be 2 into 1, okay, and we get here plus 2 again. So for this index, right, how we are getting 2, you must be assuming that, right? So 1 itself and this this array. Okay, so it's getting that, but we are doing through a calculation, so we're not iterating it again and again. We are just taking the previous index and multiplying it with the height, like that. the width into height, and we are getting the answer. It's like that. Then we'll go to the next element, that is 0, and we will leave it. Okay, then we will go, okay, go to the next iteration. So we'll make an again we compute this. So we have 1 here, and when previously with 2, so it will be 3. Similarly, we have 1 here, previously it was 1, so it will be 2, and here again we have 0. So for 3 it will be 3 only, plus, so for this 2, now it will be 2 into 2, 4. How it will come? Because see, 3 is greater than, so the previous index will be -1, so -1 minus, so this will give us 2, because 1 minus -1 will be 2 into 2, so this will give us 4, and that, and if you total these things, so how much it is? 1 plus 1 2, 2 plus 2 4, 4 plus 6 10, and 13, so it will be 13. In this way, we don't need to iterate back the portion which we are doing, the third loop which we are doing, right? So that is eliminated, and with the help of stack we can achieve this, because it will give us, whenever we will get a higher number, like we will all put in all things will put into the stack only, and still we get a smaller number, we just remove it, so it's called a monotonic stack. I'll just show you an example of monotonic stack also. So okay, so suppose this is a stack, okay, and we have number 1 7 8 6 3 2 1. Okay, we need to find something. So okay, initially I will put 1 here, okay, then I get 7, okay, and I will check if I don't want a number which is less than 7, so I will keep removing the numbers until I will get a greater number than 7, or all numbers are removed. So I will just remove 1, because no number, I will enter 7. Now I got 8. So I'll again do the same, like I want number equal to or greater than 8 now. So I'll just remove 8, 7 also, and add 8 in that. Then I got 6, then I can add 6. 6 is nothing because it's greater than only, and I want greater than only. Then I got 3, I can add easily 3. Then I got 2, easily I got. So here you can see we get a stack with only sorted ascending order things. Yeah, so that is called monotonic stack. Okay, so let's go to the code and start writing some code. I will delete this one. Okay, yeah, and here we're using the stack and that array. We're not using the 2D array. Okay, so let's do it. Okay, so for, we'll write answer first. The answer equal to 0. Okay, int I equal to 0, I should be less than mat dot length. Initially we are iterating through I. Okay, j equal to 0, j should be less than 0, j plus plus. I'm writing this code so that you can understand how to write it. See, sometimes we are able to visualize it, okay, this way we have to do it, but writing we are not able to do it. So for that only I'm writing, so it may take time. You can just fast the video and see it, okay, because I'm also thinking about it. Okay, so then we'll write height here, equal to new int. We'll make a height array that we saw, mat dot length. It will be of length of row, correct? Sorry, it will be length of column actually, not row. Yeah, and what will we do? We'll compute it for int I equal to 0. Not I will not work here. We'll need to take some other thing. Okay, And how we'll compute it? Height of GHT. I think we'll keep it outside. We'll not make it new every time. It will be same for everyone. Okay, height of X is equal to okay, if we get mat as 0, mat of I and X is equal to 0, then we'll mark it 0, otherwise it will be height of I plus 1. Okay, so if we get a 0, we'll just mark it as 0, otherwise we will add the previous height whatever present in it and we'll just get it, not I, here it will be X. If you are using too much variables, then you can get confused like me. Okay, then this is done. We can make a stack here, int. We'll make a integer stack here with an array. Okay, st. Why, I will tell you, and we'll include, like, initially if we are at 0, what will be our previous index? It will be 0. What will be our previous count, like current count? It will be also 0, right? And what will be our height at that time? It will be -1. Like, we don't have any height, right, till now, so it will be like that. So we'll just add st dot new int int -1 comma 0 comma -1. Okay, now we will iterate for the j, like we'll iterate for it. Okay, I think instead of j we can iterate for directly the height. I guess we have to yeah, it's same only. So while iterating for height, we will take int h equal to height of I. Okay, we got the height. Now we want the previous index, correct? But before that, okay, let's take the previous index, int previous index equal to what we have included in that. It will be okay. We have to make one integer now, int top. We can say it's top, and we will take by st dot peak, and here it will not add, it is push. Okay, and the previous index that we need to minus it will be st top of 0. So we'll get -1 initially. Next we will get the other index. Okay, what else we will need for that formula? Do you remember? We need the I. We have, it will be j now, minus the previous one, that is -1. Okay, and into height. We need all these things. Okay, so we have this one, we have j, and we'll also add the previous current height. Okay, if there is a previous current height, we'll also add it. So pre height will take as top of 1. Okay, top of 1 we are taking it. Okay, and int current answer equal to, we'll calculate the current answer now the same way, j minus pre into j minus pre, I will put into bracket, into the current height. So we'll get the answer. Also we'll be adding the previous one, so pre h. What are the previous height we got, right? Like if we have computed it, so that also we'll add it here. Hope you get it. This is done, this is done. And after getting this, we'll just add the same thing as we push it here, right? So we'll push it here also, st dot push we'll add what things we are going to add. The previous index, that will be j, that is the current index as of now, but when we do the next iteration it will be the previous. We'll add the current answer because that is the current height actually, so we'll add it. Okay, and what else we will add it here? We'll pass the 1 minute, we'll pass the h, yeah, the height. Okay, so if you try to compare it with what I've explained in that iterations, you'll get it what it is. Okay, so here we are taking a j, that will be the previous index, the current answer, that is the previous computed answer we got, how many submatrices we, it's not the height, it's the answer, my mistake, I'm sorry. Yeah, and next it will be the current height. Okay, current height for why? Because we will be removing it, right? So for that also we'll write a loop. Okay, here. So while, but because we don't want a height greater than the current height, we want something which is lower than it. While st dot peak, peak of 2 is greater than equal to h. Okay, we will remove it, st dot pop. So if something is greater or equal to, we'll keep removing that from the stack. Okay, and until we get a lower one. Okay, this is how we are doing it. And you see we have removed the third loop actually, and this for this it will run in m into n now. So let me check one. Okay, we are not adding this current answer to answer plus equal to current answer. Okay, yeah, and return answer. Let's try to run it. Okay, we got something pre-h, int pre-h. Okay, not written int. Let's see if 19, 21, 21. Oh, we cannot push like this. It's a new int. New int. We cannot push like this because it's an integer array. We need to push like this. Okay, we're getting one answer wrong. I need to find it. Why it's like that. Okay, so I think I made a mistake here. Instead of J, I have written I here. So we need to change that and let's see if it's working. Yeah, so it's working now. So I told you to be careful with the variables. Actually, I fumbled here. Yeah, so it's done. So here the time complexity will be big of mn. Okay, mn, because we are just traversing for every point and just calculating how many submatrices can be formed or ends there with one. And space complexity will be big of n only because we are just using this one, this array. We are not using a 2D array as our extra array. Okay, so hope you get this, hope you get the video. So if you don't understand anything, please comment down and I will try to help you and make you understand. And for such more video, please subscribe the channel. Thank you.